just introduced this thing that we've called the vertex form of a quadratic function. To see why we call it the vertex form, we'd like to look at a graph of a quadratic function. But our existing techniques for working with the graph of a quadratic function are for working with a quadratic function given in standard form. Of course, if we have vertex form, we can go back to standard form just by multiplying things out. Right, so here we have a function f of x is -1/2 times x minus 2 squared plus 5. So first I'm going to work out x minus 2 squared. Right, so x minus 2 squared, that's x minus 2 times another x minus 2. That's going to be x squared minus 4x plus 4. And so my function, I have f of x is -1/2 times x squared minus 4x plus 4 plus 5. Distributing the -1/2, I'll have -1/2x plus 2x minus 2 plus 5. So my f of x is -1/2x plus 2x plus 3. So let's see then what the graph of this thing looks like. And I'm just going to plot some points. The reason that I'm picking points with even number coordinates here, oops, I stopped copying a squared somewhere along there. The reason I'm picking points with even numbered coordinates here is that then when I multiply by this -1/2, I'm going to get integers. So I'll take -1/2 times -6 squared plus 2 times -6 plus 3. And that gives me -27, which isn't going to help me with this graph, but that's fine. Next, I'll take -1/2 times -4 squared plus 2 times -4 plus 3 gives me -13. -1/2 times -2 squared plus 2 times -2 plus 3. Oh, that's a little bit better. That gives me -3. -1/2 times 0 squared plus 2 times 0 plus 3. That's going to give me 3. -1/2 times 2 squared plus 2 times 2 plus 3. That's going to give me 5. -1/2 times 4 squared plus 2 times 4 plus 3. Oh, that gives me 3 again. And then when I plug in 6, -1/2 times 6 squared plus 2 times 6 plus 3. That's -3 again. So I see the points that are going to be interesting for my graph are these points. And then these 2 points have the same y-coordinate. These 2 points have the same y-coordinate. This point is going to be my vertex, because it's between pairs of points that have the same y-coordinate. So 2, 5 up here is my vertex, which means my axis of symmetry is going to be this vertical line. And then my other points are going to look something like this. I've got 0, 3, and -2, -3 over to the left. I have 4, 3, and 6, -3 over to the right. And so when I fill in my parabola, so flat at the vertex, and then a smooth curve to the left, and a smooth curve coming down to the right. My parabola is going to look something like that. And one of the things that we notice here is that the vertex is at the point 2, 5. Looking at the vertex form, we see a 2 here and a 5 here. So remember we wrote the vertex form as f of x is a number times x minus h squared plus k. In that form, this is the value of h, and this is the value of k. And so that's going to be very helpful to us when we have a function given in vertex form. We're going to be able to graph that much more easily because we can just look at that form and immediately see what the vertex is.